Hello all, my name is Shakil Ansari and I am a data scientist. So this is the third video of my playlist Logistic Regression from Scratch. So in this video, I am going to explain the mathematics behind logistic regression and I am going to derive a logistic regression equation. So let's start. So consider we have a model with one predictor independent variable x and one Bernoulli response variable y hat, and p is the probability of uh, y hat equal to 1. Then the linear equation can be written as p is equal to uh, b naught plus b1 x. So this is the, so you can see here, this is the same equation y is equal to mx plus c. So it is equation of linear regression. So, so the right side of the equation, beta naught plus b1x is a linear equation and can hold the values that exceed the range 0, 1. But we know that probability will always lie between in the range 0, 1. So, like as I mentioned in my previous video, the value of probability lies between 0, 1. So to overcome this limitation, we need to take the ports instead of probability. So as I have explained in my previous video, so ports, if we have success, see here, this is the probability of success, then the odds will be p divided by 1 minus p. I have explained this in my previous video. So you can see here now the equation one, this equation can be written as p by 1 minus p is equal to beta naught plus b1 x. So this will be our second equation. So now you can see here odds value can only be positive, but in logistic regression there might be a case where we have negative value. So to deal with that, we need to take a log of odds. So if we take the log of odds, then it becomes log of p divided by 1 minus p. So you can see the equation 2 can be written as log of p divided by 1 minus p equal to beta naught plus p1 x. Okay. So now we are applying here exponential on both sides. If we apply exponential on both sides, then the equation becomes exponential, like e power log of p divided by 1 minus p equal to e power beta naught plus b1 x. So you can see this is the equation. Now from the inverse rule of algorithm. So I will show you what is the inverse rule of algorithm. So you can see here, if we have this thing, b power log b x, then it becomes x. Okay, so it is a similar form like e power log into p divided by 1 minus p, right? So it is similar like e power log log something x. If you get, then it become x, right? So in the same way, so instead of this, from the inverse rule of algorithm, we can write like this: p divided by 1 minus p equal to e to power beta naught plus b1 x. Okay. So now here we are applying simple algebra, like simple calculation. So I will show you. Like see here, we have p like p divided by 1 minus p is equal to e to power beta naught plus b1. So this is the equation. If we multiply cross multiplication p is equal to 1 minus p into p को power beta naught plus b1 x. Okay, now and just multiplying this, then it becomes e को power beta naught plus b1 x minus p into, okay, p को power beta naught plus b1 x. Okay, then if we solve this, then we'll get if we keep, so if we like see here, if we do like p plus p into p को power b naught plus b1 x, then p को power beta naught b1 x. Okay, so if we take p common, then 1 plus e को power beta naught plus b1 x is equal to this beta naught plus b1 x. And if you then p is equal to e को power beta naught plus b1 x divided by 1 plus e को power beta naught plus b1 x. Okay, till here it is clear, right? Now I will erase this and I will show. So you can see here we are up to here, right? Up to here. So how we can drag up to this equation? So this is very simple calculation. So see here we have beta naught plus b1 x divided by this 1 plus e को power beta naught plus b1 x. Okay, so I will change the color. Then we have e beta naught plus b1 x divided by 1 plus, so I am taking the, if I will take the inverse of this, then it will become 1 divided by e को power minus beta naught plus b1 x. Okay, now see here, so it became e को power beta naught plus bx divided by e को power minus beta naught plus b1 x, then it become like e को power minus beta naught plus b1 x plus 1. Okay, and if we go then it will go up and it will like beta naught plus b1 x, and this is inverse, then I can write like this e को power beta naught plus b1 x divided by 1 plus e को power minus beta naught plus b1 x. So it will cancel like this, and the equation becomes 1 by 1 plus minus beta naught by bx. Okay, so now if we can see this, okay, so this is the equation for a sigmoid function. So you can say p by 1 plus e to power minus x or something like that. So this is the sigmoid function. This is the sigmoid and the graph of, this is the graph of sigmoid. So now you can see here, let's say we have this linear model. Okay, y is equal to beta naught plus b1 x, and we have sigmoid function, this 1 by 1 plus e power minus b. Then the logistic regression function becomes like this, y hat is equal to 1 by 1 plus minus, because pair y hat, so it can be 1 by 1 plus e to power minus beta naught plus b1. So now see here, in linear regression the base fit line is straight, but in logistic regression the base fit line is like yes sir. That's why it is helpful in solving when the data are non-linear. So yes, so like why I have derived this equation, because it is very important to understand like how logistic function comes into the picture from linear regression. So like you see here, like for linear regression we have different kinds of metrics, right? Like we have R square, root mean square error. Okay, so in the similar way, like there is a matrix for logistic regression that function is called cross entropy loss function. So which is used to measure the performance of this model. So yes, so in my next video, I am going to explain the implementation part by taking any kind of use case, and so there will be two more videos. So in the next video, I will be explaining the implementation part, and in last video, I will be deploying the model at Hugging Face. And thank you and happy learning.